All right, hello everyone. My name is Rodia Tamuso. I'm going to be your moderator today. Welcome to our webinar on from LOR to building machine learning solutions. I am currently serving as the SCG president of the Federal University of Technology Akure Student Chapter, and I'd like to introduce our speaker, Olawale Ibrahim. He's a machine learning developer with Earth Science Analytics. He's a first-class graduate of applied geophysics from the Federal University of Technology, Akure, with a keen interest in developing innovative solutions with technology. As a data geoscientist, he has been involved in the development of machine learning geoscience solutions in areas like 3D record property prediction, 3D and 2D seismic body of facies classification, world log analytics, and seismic multi-attribute clustering for oil and gas prospect identification. He has worked with analytic tools to provide data-driven solutions across multiple industries, oil and gas, agriculture, banking and finance, commerce, just to name a few. As a back-end software developer, he was and is involved in the development of geoscience softwares like EarthNet, OpenDeck, and others. He has won many accolades, including the first 2020 machine learning contest, and is a 2 times NICE top position paper and poster awards. Thank you, Olawale Ibrahim. We really appreciate your efforts in taking your time out of your Saturday evening to join us today. We really appreciate it. I'd like to also do a little housekeeping before we start. If you have any questions during the presentation, please type into the chat box. We'll bring them up during the question and answer session. Also, if you're not sure, please mute yourself in order to keep the quality of the sound functional. All right, thank you. I'd like to pass the mic to you now, Olawale Ibrahim.
Yeah, thank you, Rodiat, for that introduction. And good evening, good morning, good afternoon, everyone, from wherever you're calling from. My name is Alali Ibrahim, and I'm a machine learning developer with Earth Science Analytics. And yeah, I'm also a recent graduate from Federal University of Technology. I study applied geophysics. So yeah, before I go on, I would just like to know if my audio is audible enough before I continue. Rogers, please can you confirm if you can hear me properly?
Yes, I can hear you, but you can be a little bit audible. It will be better if you are more audible, yeah.
All right. What about now?
Okay, better.
All right, thank you. And yeah, just before we go into the session today, I would like to thank Sequota for the platform to share this to be able to share this session with everyone. And also I'd like to thank Rodiat for the opportunity for actually being the one to like the brain behind all this and making me to do this because I feel like this is such an opportunity for everyone actually and even for myself because in the past I've always been getting requests from folks from my colleagues alike to know how to be able to navigate this world of machine learning and data science and geoscience. And also, I believe that this session will be recorded, so we'll have a proper storage for this session on SEG Twitter, YouTube channel, so everyone could always access it after this session. So without wasting much of our time, let's just dive into it. And please, if your mic is unmuted, can you mute yourself to avoid distractions? All right, thank you. And yeah, for the session today, just like we have the topic from LO to building machine learning solutions. So we'll just be so you kindly indulge me to in some during some of the slides I'll be talking about myself, some of the things that some of my experience basically, so everyone could learn from it. So you kindly indulge me why I do that. And then for the outline, we'll be going through the introduction just like we have it now, and also some motivation backstory into why we are doing this. And then we'll look at some data science and machine learning processes, and then go into the main topic gist for today, the roadmap of geoscientists in data science and machine learning. And then finally to my own personal journey from my first Hello World when I started writing Python programs basically, and then to some takeaways, like just to summarize the whole session. And yeah, just like I mentioned before, the reason why we are doing this today is just to just to offer some, some ideas and some insights from my own experience. And I think I've been privileged to be in a position to offer some help, some guide into for especially for my colleagues that are looking into this area. And also in the past, I've always been getting requests from colleagues and friends on how to be able to navigate this. And also because data science and machine learning is quite like though I wouldn't say it's a new field entirely, but for geoscientists, it's kind of like a new skill set which should always help your career, which should help all your interpretation workflows as a geoscientist and yeah, as a geoscientist basically. So that's why I feel like it's something important for us to all at least we should be able to have an idea about it and also be able to use such skill sets in our various workflows as geoscientists. So that brings us to the next slide, which is on data science processes. And basically, what is data science? Is just it's just the act of using scientific methods to get insights from data, which could help aid business decisions and business actions, such that the business could be more profitable. And in the case of geoscience now, I think in the geoscience world, we use data science and machine learning, to be able to aid the interpretation on workflows as geoscientists to help us get more accurate results to make our work more efficient and more effective. So basically, that's just what data science is all about. We won't be going in depth into like really what data science entails, but I feel for the purpose of this webinar, it's quite important if you can mention some few things, just for everyone to be able to for everyone to get an idea of what we are really talking about. Another question someone might like to ask is what's the difference between data science and machine learning and AI? But simply put, I think I would like to, it's quite subjective now. Others might not agree with my opinion, but I think data science and machine learning, it's a subset of artificial intelligence, and why machine learning is quite like a subset of data science, but not entirely a subset because machine learning itself could also be like a different set under under AI, and we could just see machine learning as just for this webinar as just scientists, we could just see machine learning as a subset of data science. Data science itself entails data analytics. It entails data analytics as some part of machine learning itself. So looking at some of the processes for data science, just like I mentioned before, in data science, we employ data science to be able to get insight from data from the real world. When you have your data from the real world, you might have been able to collect your data from different sources or from different sources. In the case of geoscience, they might be coming from sensors, from field surveys, and etc. like that. Another thing which I would like to mention is that with recent advancement in technologies, the rate at which data is being acquired now is higher compared to the past. So it's also very important to be able to harness the power of big data in this world. So that's kind of like why the hype about data science and machine learning has been quite high in recent times. So you can always get data comes like from the real world now, just like I said, it comes in form of from surveys, from sensors, or even from like web apps like Twitter, social media, and a lot of sources like that. So once the raw data is collected, it's important that you pass in the data through you have to clean the data. And this is, when the data is coming from the real world, it might be messy. Data from the real world most times is always messy. In case of your geoscience data now, talking about well logs, you might have some very spurious readings maybe due to some issue with your sensors or other things like that. And it's important that you're able to at least filter your data such that when you're trying to use it, it's more easier for you to use. So most times when you get data from the real world, it passes through kind of processing stage in the data science cycle. And once you have your clean data set, then now you can go into exploratory data analysis. And this is quite like one of the most important one of the most important stages or processes in the data science cycle, because from exploratory data analysis you can properly analyze your data, you can understand your data properly so that you can make decisions, and you can even, I mean, you can understand your data properly, which will enable you to make very good decisions from it, which might aid your business decisions, and it can even help your interpretations. I mean, as geoscientist. So once you're able to explore your data, you might need to do that, or also you might not also need to do that, and then you pass that into the next. I mean, the insights which you've gotten from the exploratory data analysis process, you pass such insight, or you make use of such insights when you're trying to build your models. And the models and algorithm process in the data science cycle is talking about the predictive analysis of data science. With the insights which you've gotten from the exploratory data analysis, you can now model an algorithm to be able to make predictions either on future data sets, or on a data set which the model might have not seen. So this essentially is the machine learning part of the data science cycle. So once you have like a model which you've tested, which you've evaluated, which you're sure that can make predictions on seen data, then now you can now communicate. I mean, you can communicate your predictions, you can communicate the result of your predictive analysis analysis process into making business decisions in case of the science workflows. It might help you to make better interpretation, better assessment of maybe your prospects, or just your interpretation generally. And also now you can also package your results, your models into a kind of data product which the end user could properly use. It could be in form of a web app, or a mobile app, a software, or even an API, and then the user can make use of that in the real world. And
Alpha.
yeah, also talking about the structure of a machine learning model. I think that's quite similar to the data science process. Like I said, we could say the machine learning process is machine learning itself is kind of like a subset of data science. So when you get your data, you go into cleaning the data, preparing the data, and also manipulating the data. So talking about manipulating the data, we have things like or machine learning, and even computer generally is what you garbage in. Garbage in is what you garbage out. So it's important that you're able to prepare your data and have very good quality data. I mean, the more quality your data is, and also quantity in some cases, the more quality your data is, the more quality it has, your data, the better the better what you get from it. Then after that, you're able to train your model. So this is like the main parts of what a machine learning cycle or structure is about. When you have your data, then you feed it to an algorithm, and then this algorithm takes your data, and it trains on it. It learns on the data such that you can now make use of this data to make predictions on seeing data, or data that the model has not seen at all, or even future data sets. And also another thing is, once you have your train model, another thing is the train and test on data set. So while cleaning your data, preparing, one of the preparation that you have to do is being able to select a particular portion of your data set, which will be used to evaluate your trained model. So you have the trained data set, which is used for training the model, and then you have the test model, the test data which the model is going to get evaluated on. So you have different things like different evaluation metrics which could help you properly assess the performance, the efficiency of your trained model. So once you have that, I think the next thing is the machine learning cycle is quite like an iterative cycle. You're always going through the whole process again, so that like the main goal is so that you're able to have a model with some very high performance. So you keep trying to improve your model, um, giving it some more data, doing some parameter tuning, and etc. like that, just to ensure that you have a very good model. And yeah, another thing is if there are any questions, you can just drop them in the chat box. And why when I'm done, when we are done with the presentation, we just take them. So that takes us to the next thing as the next thing in this webinar, which is the roadmap for geoscientists in data science and machine learning. So personally, I think this is what I think, or the roadmap which I think geoscientists should take, because it's quite subjective and it's just my own opinion. But being that I think I think I've been privileged to go through some of these I mean to have the experience. I think these are kind of like the main things needed for geoscientists trying to adopt or make data science and machine learning skill sets in their workflows. I really do think the first stage to start from, or the first thing to start from, is selecting a programming language. When you're talking about data science itself, I mean, not talking about applying it into science or into science workflows. Professionals, they'll always say something like, you actually do not, like, the main thing is not about selecting a programming language. You don't really have to start with the programming language. Well, I think that's just data science in a broader view. But I think for geoscientists, it's important to start with selecting a programming language. Reason being that I mean, as scientists would always a programming language gives us it offers us the flexibility to be able to implement things in different ways. And also talking about data science, it's not just about programming language. You might need to learn some analytical tools like Excel, basic ones like Excel, Power BI, Tableau for big data, even a query language like SQL. But I think for geoscientists, we really do not need that. And the programming language offers us, all the flexibility we might need to work with. We might always need to do some scientific computations that might not come with some conventional softwares, etc. And I think for the purpose of machine learning, programming language is just the programming language is just the best option to go for. And there are different programming languages which you can do. Generally, I think you can almost use all programming languages for data science, but there are more that there are some that are more suited for data science, and we have them like Python, R, or Julia. So either of all these three you can select or you can adopt when you're starting data science data science journey. And personally, because I'm a Python person, I would always advocate I might be biased towards that. I would always advocate for Python, but R and Julia, they are also very good programming languages for that. I think R specifically is more designed for scientific for data science itself. But the reason why I would go for R is because of for Python rather, is because it has a very low entry barrier. The syntax is very easy. That's a very large community. There are a lot of open source content on it that would really aid and help I mean, that will really aid and help your start in programming. So once you're able to select the one you want, maybe let's say you're going for Python now, the most important thing is to understand the syntax, the semantics, the structure of the programming language. I mean, once you're comfortable with the basics, and talking about the basics for Python now, we have things like understanding the keywords, what the keywords are, how to declare variables, how to implement conditional statements, conditional loops, how to declare a function, how to make use of a function, reduce a function, and also how to make use of open source libraries, because I think that's like one of the main advantages of Python. A lot of content stays open source, and you really don't need to always implement things from the scratch. So once you're able to go through all that basic, then I think the next thing is going to using data science libraries. So once you're able to learn how to use open source libraries in Python, I mean getting the basics properly, then you can now start adopting data science libraries to use. And another thing is when you're trying to learn all these things, the reason why I pointed out this the reason why I made all these highlights is because when you're trying to learn something, especially just like we have it now, there are a lot of content. There are a lot of content online, and you might be very confused because and those contents come with a lot of, sometimes they're always different, but they have this like they're always different, and you might encounter some that you might be doing some things that you're not supposed to be doing. But as geoscientists, I really do think that this highlights which I made, or these bullets points, so to say, are like the important things that you should just look out for. So if you're taking any tutorial, either a course, tutorials on YouTube, or any of the learning platforms, these are just like the things that you try to follow. So talking about data science libraries for Python now, you just probably need like three to learn, like the most important ones. There's no crime if you go and learn, I mean, every other one possibly out there. I'm not sure if you might be able to do that. But like these three are like the most important ones, for NumPy, which helps you for scientific computation. You might need to implement you might need to implement some equations, some models in your interpretation as geoscientist, or to just to implement some theories even might need NumPy for that. It really helps for numerical computations, scientific computations, and also pandas, which I think is like one of the most important data science libraries in Python, if not the most important one, because I see Python as as Excel for data science. With Panda, I'm sorry, I see pandas as Excel for data science. So with pandas, you can do a lot of data analysis. You can manipulate your data. You can even do data exploration with it. Try to understand your data properly. Generate new columns. Generate a lot of things. Do a lot of data manipulation. And also we have Matplotlib, which is essentially used for visualization, and just mainly used for visualization. So as geoscientists, you might need to render some plots, charts, or make a geosection, display some maps, or even might need to display of seismic inline or cross line, some visualizations of the subsurface and etc. like that. Even make things like well log plots. I feel like if you're able to adopt these data science libraries and understand how to use them, when you're taking a tutorial, they might be applying. And another thing is when you're taking a tutorial, it's very important that you try to go for the ones that are hands-on and not just talking about the theories. It's always advisable to go for something that you're also able to code along, just like as the instructor is teaching, because I think that's like the most important thing. You learn by doing. So yeah, once you're able to learn using whatever exercises or projects that might be done in those courses, then now you can now transfer the knowledge of that into working on geoscience related problems. You can use knowledge from, I mean, once you're comfortable with the basics, with how the programming structure is, using data science libraries. Then now you can now work on the science related problems. For example, you can start with well logs for a start, because they are kind of like the easy projects in geoscience, maybe geology or geophysics, that you might need to work with. So with knowledge of one and two, you can now start applying them into science workflows. You can do some data analysis, some little data science with those knowledge. And also there are also some, just like I said, Python is open source. There are some open source libraries that might help you work with well logs like Latio, like Queli, and etc. So it's very easy for you to convert like a last file into a CSV into a CSV data format, so that you can make it of pandas, NumPy, and Matplotlib to work with those well log data. So I think once you're done with that, the next thing is picking up machine learning libraries. Yeah, now you can now start going into learning about the theories of machine learning, what machine learning really is all about, what just like you mentioned before, what training or a model is, what prediction is, what evaluating a model is, just a lot of theories on machine learning. And now you can now start using machine learning libraries, for classical machine learning. Like for now, we are just looking at working with some simple data like raw logs data, because you're just starting, and that's quite like the easy way to start with data science and geoscience. So I think one of the most important, if not the most important, machine learning library in Python is on sklearn, because with sklearn it offers a lot of functions, a lot of methods which should help you to train your model, evaluate your model, even perform things like preparing your data, having your train and test data on state, and evaluating your model comes with a lot of functions for that as well. So I think once you are done with that, also you would also work on some projects in whatever course or tutorial content you're making use of. You also work on some exercises like that. And once you grab the basic idea of using such libraries, I mean the sklearn libraries, there are also other machine learning libraries for that. Then you can now transfer this knowledge again, just like the previous steps. You can transfer this knowledge into working on geoscience related problems. So you can use this knowledge to work on geoscience tasks like prediction of missing logs, species classification. Another thing that you should also learn, when going through the theories of machine learning is, there are different types of machine learning. Yeah, we have supervised machine learning, we have unsupervised machine learning. We also have different types of tasks in machine learning. And the basic ones are like the classification tasks, the regression tasks, and though there are some others, but basically, and also for like when you're working with the tabular data, 2D data like your well logs, you will always just be posed with classic classification and regression tags. So prediction of missing logs of missing sections of logs is a typical regression task. While facies classification from well logs trying to classify if a data point for is a is a particular lithology type, like maybe sandstone, maybe shale, limestone, and etc. So once you're comfortable with that, I think the next thing is yeah, now you might need to work on other type of data structure. Basically we've just been looking at when you're talking about 2D data like your well logs, these are kind of like structured data, because they come in rows and they come in rows and columns, and that makes them structured. But in geoscience, we do not just have structured data, we also have unstructured data. That examples of unstructured data like images, audio data, and all. But in geoscience, I think it's just yeah, in geoscience, the main one is just images. There is just images, and you might need to work on unstructured data, and you might quite not be able, or it might not be very easy for you to make use of sklearn and all these other classical ML libraries to work on unstructured data like images. Like your seismic volume, your 2D data, your 3D seismic data. So now it comes so that's what brings us to the next one, using deep learning frameworks. Because with deep learning frameworks, it will help you to be able to implement some things like neural networks, which will make you work on this type of unstructured data. So we have different there are also different frameworks for that. So when I'm talking about frameworks, I'm just talking about like maybe like open source codes which have been written to simplify and make implementations of some particular code more easier. So you do not have to write code from the scratch. And there are open source creators that have written programs to make, like in the case of deep learning frameworks now, to make implementations of neural networks more easier. So you do not have to implement all the theories of neural networks from scratch. And it's just very easy. Just very easy for you to build once you're able to learn a particular deep learning framework. So for starters, you can either choose you can start with TensorFlow, because TensorFlow has a lot of functions, and it's quite like it's easy to use. It's quite easy to use because it has a lot of abstractions compared to maybe like PyTorch, which offers more flexibility, which is just my own just my own opinion. And once you're comfortable with that, once you are able to do deep learning, and also you would have learned some theories on when it comes to neural networks, different types of neural networks, artificial neural networks, convolutional neural networks, and also possibly you should have done some projects in whatever course or tutorial you're also doing. And also with the knowledge of this, then you can now transfer that into working on geoscience related problems, just like I said, seismic fishes and classification, either from 2D data or from 3D data, You can do some other things like prediction of faults or identification of geobodies from seismic volumes, etc., like that. So I really do believe that, or think, and I believe that all these steps are what is quite like needed for geoscientists in the world of trying to adopt or make data science and machine learning a part of their skill sets to aid interpretation workflows and make and get better with interpretation. I don't know if there are any questions in the chat box now. Maybe I should take one or two before going to the next slide. Okay. Radiat, are there any questions now, or can I continue?
Yeah, there are some questions in the chat box. Do you want us to take them now?
Yeah, let's take one or two before we go on.
All right. So we have a question from Rakib.
Okay.
Just a moment, please. All right. He said, is machine learning a complex tech skill set, and how can we break it down for easier learning?
Sorry. Come again, please.
He said, is machine learning a complex tech skill set, and how can we break machine learning down for easier learning?
I think. Sorry. Let me look at. Okay. I'm talking about if machine learning is a complex skill set. Personally, I wouldn't say it's a complex skill set, but it's something that you have to learn for you to be able to. It's something you have to learn and something you have to know. And just like I showed in the workflow now, I mean, there are quite like some important things you need to do before you can get into machine learning itself. Machine learning is not quite like an abstract. I mean, if you want to do applied on machine learning, I'm not just talking about the theories. There are things that you need to know, or things you must be doing before you get into actually doing machine learning. And the most important one is the programming languages. Yeah, the programming languages. And it takes consistency. It takes some sort of consistency to get good at something like or it gets good at something like a programming language. So talking about machine learning itself, I wouldn't say it's a complex skill set. No, it's not. It's just something that once you try, once you put your heart to it to learn it with consistency, you would always. And I mean, we're all always learning on it, and there's really no like end to learning, right? So I don't think it's a complex. It's not a complex skill set once you're devoted to it. Yeah. All right. Yeah, I
Okay,
think I'll go
I
to the
guess
next.
that
Okay. What do you say?
should we go to the next question?
Yes, let's take one more question before we continue.
Okay, Maduka Mensah said that is the training the data is it where the machine learning comes in?
Yes, exactly. Training the data is like the main part of machine learning itself. Yeah, that's what makes your machine learning when we're talking about machine learning models, there are some processes that leads to that's like combines to form a machine learning model. But training the model with a particular algorithm is quite like the main gist about what machine learning is about. There are different algorithms which you could use. We have simple ones like linear. I think a lot of us must have done linear regression in schools. Simple ones like linear regressors. Those are like the linear models. We have complex ones like the neural networks, artificial neural networks, convolutional neural networks, even tree-based models like random forest, decision trees. There are also algorithms, machine learning algorithms, which helps in training the data sets, the model, so to say. Yeah. All right. I think I'll go to the next slide now, and hopefully to offer more light into what we're talking about. So the next slide is talking about my own personal journey my own personal journey in machine learning on programming so far, and just permit me to talk about myself now. And so yeah, in 2017, I started programming. I think that was in 2016 through we had a particular course in first year then on basic, and that was when I wrote my first programming on code. And then in 2017, I wrote my first Python my first Python program through a course CSC 202. And then after that, during that time, I really didn't have interest in programming like that. As a matter of fact, the course seemed quite like abstract and very, very, it seemed quite strange, and not until, not until the day before the final exam before I was able to get some things. Basically I had to cram to the exam or just to have a good grade in it. So I really didn't have a lot of interest in Python then. But then in 2018, I started developing interest in data science. I didn't know how this happened, but then, at least in Nigeria, then there hasn't been a lot of hype about data science, and I find myself with some tutorial content videos which a friend actually gave to me then. And I remember I was doing I was implementing and doing what the instructor was doing with NumPy, with a particular tutorial from pairing data then. And I just found myself doing it, and I kind of liked that. Another thing was that in 2018 I was invited to a particular meetup, a computer programming meetup by a friend, DSC. And the reason why I put this, why this is here is because I think this was very important in my journey, because from there I was able to have a study group, so to say, that was, I could always get some study resources and, materials, contents from. And then in fourth year, that was in 2019, from like January to like June, I wasn't really doing, my interest in data science kind of went down, because I wasn't really doing that due to school activities, and due to school activities, basically assignments, tests and exams like that. So I wasn't really doing much of that. Not until I went for my internship. That was like July to December, and I had the opportunity to be able to, I had the opportunity to really to learn some things. I was able to do extensive study. I went back to my interest in data science, and I was able to do extensive study, and I regained that interest back. I had some during my free time. I was always able to, I was taking a particular course on EDX then by Microsoft, Principles of Machine Learning, and I was just doing some study then. And also another important thing that happened in 2019 was I was also able to participate in my first cargo machine learning competition. Cargo is quite like the data science machine learning community worldwide. So I was able to participate in my first cargo machine learning competition through a data science Nigeria bootcamp qualification then. And I added this because I think it formed like one of it formed like it was a very important part for me, because through the competition I was able to, I was quite like a little obsessed with competition then, and it was very challenging for me then, because I always had to, when you are engaged in the competition, you're always trying to improve your model, and it pushes you to try to make some research, do some study on how you can always improve your model, learn some new things. And I was just doing a lot of that something, and at the time I wasn't really aware of like, how important it was, how important those study was for me, until, just looking back in recent years, how foundational that had been for me. And yeah, when I'm talking about when I talk about my journey applying data science, machine learning in geoscience, I kind of use the word like it's been unconventional, because I didn't intend to go into applying data science and machine learning in geoscience. I just wanted to do data science and machine learning. So I just did a lot of things. I also didn't have a proper guide then. I was just, going in and out of things, and I didn't have proper structure. There were a lot of information, a lot of knowledge out there on the internet. So I really didn't have like proper guide of what to do and what not to do. So I just find myself, competing, competitions, and that's really, that really helped me. But I mean, for geoscientists looking into applying data science and machine learning, you really do not need to go through the competition route. You really do not need to go to competition route, but just working on projects and just working on project and keep learning. I think that's quite enough if you're just looking to apply data science and machine learning in your geoscience workflows. So yeah, something else okay, in 2020 that was fifth year. We're supposed to, yeah, after my internship, went back to school. I had to go back to learning Python basics because, I mean, all through the previous year, you could pick a code from Google, try to tweak it or try to make it work for a particular task. And I discovered that, and also alongside during the competition, I had a study group, so my other friends that were involved with this. We discovered that our Python on basics was not very strong because it seemed like we could not always rework codes to make it work. We were not getting some things. So, we decided to go back to learning Python basics again. So I went back to writing my my first Python code again, so to say, hello world in 2020. Yeah, 2020 while school was in session from around January to March. So we took a particular course on that, which came with a lot of projects on web design, web scripting, web scraping, testing, automation, and also some part of data science itself. So I think that was very important and also foundational for me because it really made me I felt like I was a, a Python developer then compared to before. So with knowledge of this and also some of machine learning, which I'd also be doing at the time, also then I picked up I picked up on TensorFlow to be able to implement some neural networks, do some deep learning, and one of the projects which we worked on, it was a group project with my friends, was on computer vision for rock some identification. So we had some rock samples in the petrology lab in school then, and we decided to work on some sort of projects whereby we can, identify rocks just by taking a picture of it. And the aim then was to incorporate this model because we had the model working and giving a very good accuracy. And it was like we wanted to incorporate it into a kind of web app. So yeah, even if students go for field trip, they go for field trip, they always take pictures and images. We could always still leverage on those images to always train the model. And we're just trying to build a app, just working on something basically. Then, though we're not able to push the project into production, but that was something that, and yeah, I also included this here because I think that working on projects really helps your learning, and it was one of the things that helped my learning. Even today, I mean, my current company while doing a similar project, there's a very similar project to that, and every other project I've done all through my journey, they have always been quite like instrumental in my learning and even in the opportunities which I've always gotten. Another thing was working on Petrol, which was a Python open source package which I made, which I was able to release then. So that was in 2020 during the pandemic, and I was just trying to do something related to petrophysics, Python, and just some little software development. And though my knowledge of petrophysics wasn't really strong then, but I was able to always consult my seniors, my senior colleagues that had done this, especially those in geology, trying to be able to do some package some functions for rock property predictions like porosity, permeability, water saturation. And that's actually helped. It really helped me because apart from just the programming part, I was able to gain some domain knowledge, which I not even gotten from classrooms, from lecture rooms. And yeah, so after that, yeah, still in 2020, I was able to work on a particular project, I was able to work on a particular project, prediction of missing logs from some well-log data then, helping out release some data sets. That was in 2018, the bulk data set. And I was able to pick some few wells, about 6 wells from it. And I used all the words for training. I used all the words for training the model and two other words for evaluating the models. And I just showed it to my I had the mentor, then Dr. Fatani Fauci. I showed it to him then, and it was of the idea that why it was a good work, and they could even write the paper from it. And then I was like, wow. And we went ahead to do that. We co-authored the paper together, and at the end of the day, it came out to be like the best poster, the best poster from, I mean, from the NAPI conference on that year. And another thing was that I also, I was participating in a lot of competitions. I was participating in a lot of competitions that was really helping me. I mean, it was really helping my learning. And so one of the most important ones was the first machine learning competition, which was prediction of little facies from well logs. But 98 wells were provided for training the models then, and 10 was used for testing for the leaderboard and 10 for the blind on boards. And I was fortunate get to come out as first position in that competition, and it gave me. I mean, after the competition, I started getting a lot of requests from individuals, even from companies then, and it really just gave me a lot of exposure then, and it was something I was, I mean, still thankful for up to now. And also, I learned a lot. I learned a lot from there. I learned a lot from there. And just after that, after the old 2020, why during the pandemic and during the industrial strike, also strike then. And also I mentioned that because I had a lot of time in 2020 to work on all these projects since school wasn't in session. And just after that, then 2021, that was my fifth year. My school resumed back, and I was supposed to work on my bachelor's on thesis. And I mean, right from my internship in 2019, I always knew I wanted to work on machine learning. I wanted to work on machine learning for my bachelor's on thesis. And also, I didn't want to do something related to well logs because I kind of felt like I had enough, at least to some extent, some knowledge in that extent. And for my thesis, I wanted to work on something new, preferably seismic, something that would be challenging, and in the process, I will get to learn more from it. And I was opportune. I mean, I had the privilege to get an opportunity to work. I mean, a particular geologist from ConocoPhillips then in Norway asked me to work on unsupervised seismic from facies or mapping using a particular SOTA methodology for image unsupervised image classification. And I took the project then because I had not done something on seismic before. My knowledge of deep learning wasn't really strong as well. I mean, talking about unsupervised clustering using deep learning, I really didn't have an idea of that. And also, I just felt like it was a very good opportunity for me to learn a lot of things, regardless of what the outcome of the project would be. And I think this is one important thing. I mean, for most of my colleagues, yeah, for most of my colleagues, should always be open to new learnings because only from pushing yourself to try new things. That's the only way you can learn and improve yourself. So I was able to take on the project, and I mean, at the end of it all, I was just made me better. Just made me better. My knowledge, my domain knowledge improved. I had more understanding about seismic data, unsupervised clustering, etc. And also, my knowledge, my PyTorch knowledge really improved then because the models, I mean, the methodology that the authors implemented was in PyTorch, and it really just helped me all around. And then I also got the opportunity to work to work remotely with a geoscience software company in Netherlands, and there also I learned a lot of things because I was able to do more geoscience stuff that that was related to machine learning. I was able to implement supervised classification, supervised regression on well logs data, seismic data, geobodies identification, just a lot, and it really helped me. It really helped me then as well. And also, I took some opportunities with TechPet. Actually started, I mean, into the corporate world with TechPet. I got my first opportunity with TechPet, and also with USAT Technologies. And also another thing, in 2021, I was also still able to work on a particular competition, the SEG competition with a group of friends, Gamaliel Adun, Matthew Oke, and also Anwala Shinanke. And the competition basically was to work on was seismic form fishes on classification from 3D data. And it was a global competition, so to say, organized by SEG. I was able to come out first position and third position for two of the seismic volumes used for evaluation. And all these experience are just been like really good for me because it helped my learning and I was able to improve at taking all these opportunities. And then finally, then in 2021, I graduated from school and I'm currently working with a science analytics as a machine learning developer. Still learning and still building very interesting stuff. So I think that's just my own personal journey so far. I think there's some few things you might be able to pick from it, and yeah, that's just it's basically. And yeah, so I'll just go to the last slide now just to summarize some things. And yeah, some key takeaways, especially for my colleagues, would be, the most important thing is self-development. Always being, just always pushing yourself to continue learning, just continue learning, taking courses, videos, working on projects, and etc. And also another thing is to be able to focus on one thing at a time. For my own personal journey, I think my journey didn't take off until I decided to focus on just on machine learning. At some point while I was learning on Python, I was dabbling in and out of some different things. I was taking on web development then, and just learning different things that at the time I was even going for copywriting and for some weird reasons. But when I decided to focus on just machine learning, I think that was when I started seeing like the gains and yeah, I started seeing the gains from it. Another thing is to have a study group. I think at each point in my journey, then I always had when I always had the study group was when things were really going. That was when I was really learning a lot because having a study group helps you. It helps you with accountability, and also you're also able to learn from what every other person is learning from. And I also think consistency is key because programming is not something that you live and you do today and then you leave for like a week and coming back to it. It might require you to start from scratch again. So when you're consistent with it, even if it's just like an hour or 2 hours in a day, it really helps. It really do help. And also working on projects, just like I mentioned, even in my personal journey, a lot of times I was working on different projects, and when you're working on projects, it improves your competency, it improves your competency, your learning, your knowledge, and just a lot. And also seizing opportunities to be better. I think that's very, very important. When you're able to seize opportunities that pushes you, that challenges you. Just like when I had my bachelor's thesis, then I took on the opportunity because I knew that I didn't have a lot of knowledge then on the particular topic I was working on, but I knew that at the end of it all, I'll come out better from it. And also continuous learning. Regardless of where you might have gotten to, always keep on learning and just keep on learning. Learning never stops, right? So yes, I think that's just really wraps it up. And if there are any questions now, I think it would be nice to take those questions. Already, let me hand over to Radiat now. Yeah, thank you for listening.
Okay, thank you so much, Olawale. I think we have some questions here in the chat box, but I think some of them has already been answered. So I'll just look for the ones that are yet to be answered and read them out. So
Well,
after Anibaba said you should give more examples of projects that can be done at each stage, that is after learning data science, and then examples of the projects after learning machine learning and deep learning also. Did you get that?
sorry, I didn't get the question. The question is from who?
After Anibaba. If you are on the chat, Afsa, can you unmute yourself and ask your question?
Okay, I think let me just take the questions from the chat box.
Okay,
I think I can
but
see.
she said you should give her examples. Okay, that's better.
I think the first question I can see here, apart from the one I've answered, is that what are the best techniques for handling outliers in the data sets during during data preparation? I think there are different different techniques for handling outliers. I think you can visualize your data sets. You can create some plots, visualize your data sets, or yeah, visualize your data set, or you could do some kind of data correlation just to check. But I think visualizing your data set would help you to be able to set a proper cutoff to use to remove outliers from your data. Then when the input variables are poorly correlated, okay, with the target variable, what is so I think these are quite like advanced questions and not really in the scope of this webinar though. But what are the when the input variables are correlated with the target variable, what is your advice in such case? So I think when you have input variables poorly correlated to your I think for machine learning you might not always be sure of what's really going on, because you might decide that you want to drop poorly correlated targets, and you might be using a different algorithm that correlation does not really matter with that. So it also depends on the algorithm that you're using for you to determine if you want to drop columns, drop variables or not. So the next question is I have been learning Python programming for a while. It has been somewhat challenging. Kind of okay. Yeah, I'll be dropping my yeah, we'll try to make a post post on after this webinar, and we'll be dropping some links that will help those open or looking at starting in data science and machine learning. Some links to some Segum repos, and even to my personal GitHub repo. There's some projects which you might like to which might help you, and some codes which might help you actually. And please give more examples of projects that can be done at each stage. That is after learning data science. I think I showed some of these projects in my slide. Um, yeah, I showed some of these projects in my slide, and would also try to make the slides available so you can have access to that later on. But basically, when you're done with, I mean, for data science, maybe for machine learning, some of the projects you can work is prediction of missing logs, prediction of missing sections, classification, fishes on classification, mythology classification, and also more complex ones like faults prediction, identification, seismic fishes on classification as well. Yeah. And what is the best way or approach to get into machine learning? As a newbie, I think the first thing is, just like I mentioned, picking a programming language, preferably Python, picking a good tutorial content or course for that, which is hands-on, which really simplifies things. And also as well, we try to put some links to some courses which you might take that would help that would help you with that as well. Next question, does deep learning, the neural network series, improve performance when compared to conventional? So usually most times I mean, it depends on what you're working on. When you're working on structured data like tabular data, most times the conventional machine learning models are better. But when you're dealing with unstructured data like images, text, neural networks might perform better. So the next question, which online learning platform would you recommend for learning on machine learning and data science? Yeah, I think I might recommend Udemy, and also I can recommend Udemy, Coursera, and yeah, Udemy and Coursera I can recommend those two. But what is more important is the tutorial itself. Ensure that it's hands-on, and at least during the early stages of which you're able to understand you're able to understand and follow with the instructor. The next thing, okay, how can one join data geoscientists community? There are a lot of geoscientists, maybe not a lot, but I know of one software underground. You can just search that on Google. You're able to join their Slack community just with that. Um, the next thing, from your experience, were you able to pick your thesis and propose it to be yeah, I was lucky to be able to, yeah, I was lucky to be assigned a particular I'm sorry, please give me a second. Yeah, for my bachelor thesis, I was lucky to be assigned a supervisor that allowed me to be able to work on what I wanted to work on. So I was able to propose that. So I submitted a proposal, and just like I said, the person, my external supervisor would assign me would give me the project, give me a proposal to work with. And let me just skip to like other questions. Let me skip to other questions. Experienced geoscientists already use Petrel and other software for reservoir modeling. What is the difference between applications of ML to geoscience and what Petrel does? I think Justin, though I'm not very familiar with Petrel for machine learning, but I think just in recent years or maybe in the past, Petrel has the plugin for neural networks. So I do not I'm not entirely sure how to answer how to entirely answer that question. But I think normal modeling is different from machine learning or modeling. I think though there are some algorithms that are implemented for normal modeling, but I think machine learning modeling is different because in machine learning modeling, the main focus is on the data, learning from the data, and not implementing maybe like some maybe equations or some assumptions to some model assumptions on basically. What career path apart from being a machine learning developer can I get with machine learning? Okay, I think this is a good one. The career path, you can go into machine learning in geoscience as a data geoscientist. You're the data geoscientist, so you're applying data science workflows in for geoscience interpretations. You necessarily do not need to be a machine learning developer, software developer to be involved in this. Um, yeah, I think that's all the questions for now. And yeah, I'd like to thank everyone once again for I'd like to thank everyone once again for listening in and joining in on a weekend. We actually didn't plan this well, and we are sorry for taking part of your weekend for this. And also, I would like to thank sorry yeah, again, I would like to thank Seg Futa for the opportunity and every other person that is on call. And also, I would like to thank I would especially like to appreciate Tanya, who is my CEO. I think she's on call here, and I'd like to appreciate her for coming in and for coming in. Thank you so much. Rudyard, you can I think you can take over now. Or if there are any more questions?
All right. Thank you, everyone. If there's anybody that has a question, you can unmute yourself and ask. So I just want to try to share the our YouTube channel, but you can check YouTube and search for Society of Exploration Gypsies Futa. So we'll be posting the recording of this video there. So I don't think anyone has a question. So Wale, you can drop your LinkedIn details so that they can connect with you if they have any other question they want to ask. Okay, you can unmute yourself after.
Okay, good evening. From your description, you said you're a machine and a backend developer too. So I want to ask, were you learning backend alongside while trying to learn data science and machine learning, or you had to learn one first, then switch to backend? Because you said we should focus on one thing at a time. And I know learning data science and machine learning, you have to also know how to put it out, like wherever you've developed for like your end user to be able to use it. So how did you learn? Did you learn them alongside each other, or you had to learn one first, then learn the other one next?
Nice question. I think for applying data science in geoscience workflow, just like I mentioned, there are like different career paths. But majorly, if you're applying geoscience data science in geoscience, that makes you a data geoscientist. Like Wafa. that makes you a data geoscientist, and you really do not have to be a backend machine learning developer. But I try to go into that part, or I'm still trying to navigate that part because that's where my interest lies more in the software development part, and not like the interpretation parts of geoscience, machine learning together. So I try to, after going through the process of adopting data science in geoscience, I'm looking into the software parts, the tech parts compared to the geoscience part. So that is what kind of makes me a backend, more focused on the backend parts of it. But I mean, for geoscientists, just looking at using data science and machine learning, I think it's just you really do not need to learn on backend skills at all, because if you'll be working with working with companies, working with companies, you don't have to you don't have to push the products to the users yourself, except you are willing to. Except you want to go to that career, you want to navigate that career path yourself. I don't think it's very necessary for that.
Okay, thank you.
James, please, can you unmute yourself and ask your question? Can you hear me, Wally?
Yes, I can hear you.
Okay, I thought there was someone raising up. Okay, I think yeah.
Hello, it's me. I raised my hand to ask a question.
Okay, go on.
Yeah, I wanted to ask where to source for geoscience data for practice, if you want to actually practice machine learning.
Yeah. So there are open source some contents for that. I think I have some drives for open source. Yeah, I have a particular drive. No, I don't have a particular drive, sorry. But I have the link to a particular open source drive for some that data. And just like I also mentioned, if you're looking at working with some well logged data, Equinor released some data sets in 2018, the Volk data sets. You can just search that online, and you'll be able to access that. So we'll try to make up post that would have some of these links to some courses, to some open source some data which you could have access to and work with as well as codes implementations, just to help anyone. Yeah.
Thank you. God's power. You can unmute yourself.
Gospa, please unmute yourself and ask your question.
Okay. Good evening, everyone. Thank you, Ali, for the presentation. It was really quite insightful. I don't know if you can hear me. Can you?
Yes, I can hear you.
Okay. So I just wanted to make a suggestion for a sustainability, more kind of. I suggestion is more like can we create a WhatsApp group chat, have a forum where those that are interested in moving on into this space, like I myself, and I have really started.
Yeah, I think that makes sense. When we planned on this, I think we would have made would have made it to be like participants in this webinar should have registered so that we have access to everyone's emails and contact details, so we can easily create a WhatsApp. Rodiat, I don't know how we are going to do that, such that we can add folks into a WhatsApp group and share more information or continue after this. Maybe we share a LinkedIn post after, just for anyone looking to join in. Or yeah, I think we'll discuss modalities of that maybe after this webinar. But be rest assured, we'll communicate some back across to everyone.
Okay, just try to check our LinkedIn page for updates. So you see it there. In the absence of no question, please can everybody turn on their video? We'd like to take a capture. We like to capture everybody. Thank you.
Radiat, are you doing that already?
Yes. Okay, you can also do it from your end, Wally. But
I'm not sure if I can do it.
okay, I'll do it. I'll do it now.
I think most people have their videos off, which is fine. Yes.
Okay, I'm trying to. Okay, I think that would do. I'm done. All right. I really like to thank everyone for taking time out of their Saturday evening to join us. We would like to see you in our upcoming events. So thank you very much and enjoy your weekend. Stay safe. We love you. All right. Thank you. Bye.
Yeah. Bye. Thanks for coming.